everyone, Bella here, bringing you some mission rocket science from the launch pad. We're back sharing some of our missing mass unit plan. This is Missing Mass Rocket Launch. Last time, we talked about physical and chemical changes and the law of conservation of mass. We also did a pretty cool experiment to show those concepts in action. So, what does a chemical reaction have to do with the rocket launch? The launch of a rocket depends on the thrust that is great enough to overcome the weight of the rocket. Thrust is created when a propellant or fuel changes from a solid or a liquid to a gas after it's exposed to an external heat source. This is called combustion, and it's an exothermic chemical reaction. We dive deeper into exothermic and endothermic chemical reactions in our next video when we explore the lesson plan, Feel the Heat. As we talked about in our last video, in the law of conservation of mass, in a closed system where nothing is allowed in or out, matter is neither created nor destroyed. Here is the chemical equation for a model rocket engine. As you can see, the total number of atoms in the reactants is equal to the total number of atoms in the products. While the combination of atoms changes, the number of atoms does not change. Therefore, the mass doesn't change. Time for a rocket launch. In this experiment, we want the students to identify the data they think that they need to collect. But today, I'm going to help you out. We are going to be launching the cosmic ray rocket using a B-64 engine. We are going to measure the mass of just the engine before launch. We have 18.85 grams. Now we're going to add our engine to the cosmic ray. I've also already loaded 4 sheets of recovery wadding. Let's see this law in action. I'm going to go ahead and prep this rocket. The range is closed. 5, 4, 3, 2, 1. That was a great launch. Now it's time to measure the mass of the engine after launch. We have 10.45 grams. Those numbers are not the same. What happened? We lost 8.4 grams. When the fuel changed from a solid to a gas, the exhaust that came out and what's left of our engine had the same total mass that we started with. But in an open system like a rocket launch, where mass and energy can be exchanged with the surroundings, it's difficult to measure the amount of carbon dioxide that escaped. We do not recommend using a balloon here to try to trap the escaping gas, like we did in our law of conservation of mass lab. That was a closed system, and this is an open system. I hope you now have a better understanding of how a model rocket launch can be used to create a model of chemical reactions and the law of conservation of mass. Check the description for the link to the full unit plan and all our other free resources. If you enjoyed this video, please like, subscribe, and hit the bell to be alerted to new content. Happy launching!